Solid spherical ball is rolling on a frictionless horizontal plane surface about its axis of symmetry. The ratio of rotational kinetic energy of the ball to its total kinetic energy is A 2 by 5, B 2 by 7, C 1 by 5 and D 7 by 10. So we are asked to find the ratio of rotational kinetic energy to that of total kinetic energy. So we know rotational kinetic energy K rotational is equal to half I omega square. So in case of a solid sphere we have 2 by 5 mR. In a moment of inertia of solid sphere is equal to 2 by 5 mr square. We have half into 2 by 5 mr square omega square. Now let us take the total kinetic energy K total. We know for a rolling motion total energy will be equal to K translational plus rotational kinetic energy. So we'll have half mv square plus 1 by 5 mr square omega square. That's because we already know K rotational. So for pure rolling motion we know omega is equal to V by R. So we substitute it over here and we'll get half m V square plus 1 by 5 m R square V square by R square. R square get cancelled and we'll get mv square, both side mv square into 1 by 2 plus 1 by 5. So we have 7 by 10 mv square. Now here also we have to substitute for omega square. K rotational becomes 1 by 5 mr square v square by r square will become mv square. Now we just have to take the ratio K rotational by K total is equal to 1 by 5 mv square by 7 by 10 mv square. Here we can cancel mv square, 5 and 10, 2 will get, take 2 to the numerator, will get 2 by 7, which is our option B.